Okay, today we are talking about stretching and shrinking. So number one there, you'll be able to determine horizontal and vertical stretches from an equation. So basically we're going to give you an equation and then you have to figure out how the graph should go. And then how to be able to graph stretches and shrinks applied to parent functions. It's pretty much the same thing. Well, anyway, 12 inches, what's that? So, a foot in the door, very good. And can anybody figure out the other one? Last hour I had a really creative suggestion, but I'm not even sure what the right answer to that one is. Can't do, can't do, can't do, can't do. It does seem like the 4 should be important, but somebody said the same thing that you said. Say it louder. No. The thing you said at the very beginning when you're no can do. It seems kind of like a stretch because it's can't, no cans. There's no can do, but I don't know if that's really it. Anyway, let's move on. Stretching and shrink. Find this page. See that M? It's really not that complicated. If I want to stretch it and make it twice as tall, it's going to look like this. Do you get how these points don't move? It's because they don't have any height. So when I try to double their height, they don't go anywhere. Okay? Or if I want to make it, what's this half in front? That's not doubling the height. What's that doing? Cutting it in half. So it's going to be half as tall. So I can go through at each point and take it and go, oh, half as tall as it used to be. What about the points that are at 0? They have 0 height in the first place. So half of 0 is still 0. So then there's the final answer. Are you getting the idea? Okay. Now, why do we have these XY tables? Because they get more complicated, and they will very quickly here, but we're going to start with one easy one here and show you how to do it when they are more complicated. So what are the key points here? 0, 0, put it on the chart. Make it, first of all, make it an XY chart. Put an X and a Y in there. And then 0, 0 is one of my points, and 1, 1 is another point. And then what's this spot right here? 2, 0, and then 3, 1. And then 4, 0. Okay, so I got a bunch of points. Now, when I do the 1/2 in front, this is crucial now. Stuff that's in the front are on the outside. Like if I had put a +5 here. Stuff that's on the outside, those things are up-down things. So, what controls up-down? The X or the Y? Y controls up and down. So, if I'm going to take all my y's and put a 1/2 on them, then that means I should just multiply all my y's by 1/2, timesing by 1/2. Because look at here too. F of x is the same thing as y, isn't it? Some of you aren't paying attention. Stay with me. If there's a 1/2 in front of the f of x, that means a 1/2 times the y, because f of x is y. So 1/2 y. So I'm going to multiply all my y's by 1/2. So times 1/2, times 1/2, times 1/2. And 0 times 1/2 is 0 still. 1 times 1/2 is 1/2, 0, 1/2, and 0. Then what do? I graph this point, 0, comma, this point, 0. 1, comma, 1/2, 2, comma, 0, 3, comma, 1/2, 4, comma, 0. If I actually graph those, it'll end up in just the same place we just talked about. 0, 0, 1, comma, 1/2. This part right here is right there, etc. Now, why go through all that work on a table like that? Because when you could just like go through and double everything or cut everything in half and do it by seeing it. I see, it's half as tall as it used to be. Because you're going to be doing problems like this. And it's really hard to say how should this look if it was half as wide. It's really hard to know exactly where to graph it. So I want you to skip to this one with me next. Skip down a couple slides. And what are the key points on this guy? Well, let's make an XY chart. X, Y. And then let's put in some numbers like -3, 4. Make a list of all the important points. -1, 1. X and Y intercepts are important. Always include the X and the Y intercepts. Now in this case, the teacher made it kind of cruel because it doesn't come out to have a nice Y-intercept. That's okay. It's about 2.7 or something like that. So 0, 2.7. Remember, if it's kind of hard to tell, well, then that's okay. If your graph on that point, it's kind of hard to tell. All right, next spot I would pick is this top of this little half circle, and that's at 1, 3. And then I would have 3, 1. And then the last thing I would have is that guy, 6, -3. Okay, now do you remember what we just did a second ago? We went through and multiplied all the y's by stuff, but this time it's an x thing. It's a left-right thing, and x controls left-right. One more thing. When you're on the inside, you remember how you can't trust it? So you don't double all the x's. You cut them all in half. That's correct. And the easy way to multiply them all by half is to put them all over 2. That means divide by 2 means a half, isn't it? So I'm going to put these all over 2. And 0 over 2 is 0, so I'm going to leave that one alone. 1/2. 2 over 2 is equal to 1, so I'm going to make that into a 1. And 6 over 2 is equal to what? 3. There's all my new points. If I graph that, I will have my little squiggly shape cut in half widthwise. Okay, so I want you to graph all those points right now on your graph. I'm going to come by and look at them and make sure you are doing it correctly. I have made the points for you. All I'm asking you is to graph them and see if the thing is really narrower than it used to be. You done, or question?
Question. Your second to last point in your table.
Oh, it was a 3, 1? Thank you. Everybody look. He noticed that I thought this was a 2, but it was really a 3 right there. So if that's really a 3, 1 and I cut it in half, that should be 1.5. So that should be a 1.5 on the table. Or 3 over 2. Same as 1.5. So now you get to play connect the dots. You graph all these dots, like -1.5, 4. And it's right there. I'm going to pause for a minute while you work on that. Okay, overall kids did really well on that one. If you just look at each of these blue points and make them half as wide as they used to be, that one doesn't have any width. That's a confusing one. So this point stays right on that axis. So basically it looks like, and that's half of that, and this is halfway across here, so it should be right about there. Should look like that. Okay, those can be tricky without a chart, so I strongly encourage you to learn how to use those charts. I'm going to do one more with you. I want you to try, would you rather make it half as tall or twice as tall? All right, let's make it half as tall. So we'll do this guy right here, and that's X, Y points, all of those same points. If you can copy them over from before, just listen to me. -3, 4, and -1, 1, and 0, 2.7, and 1, 3, and 3, 1, and last is 6, -3. I would take all those. I would figure out, should I multiply my y's or my x's, and should I use a half or 2? Figure out what to do. Remember, it's on the outside. You can trust it. Pause for a second while you crank that one out. I am back from the break there, and final answer was to multiply all the y's by a half. So that half 4 becomes 2, half the 2, or half the 1 becomes a half. Half the 2.7 becomes about 1.35 to be exact. This is about 1.5. I am recording. Half the 1 is a half, and half the -3 is -1.5. And if I actually graph all of those things, it should become half as tall. And if you think about this point right there, -3, 2, It's half as tall as it used to be. It used to be this tall. Now it's only that tall. Okay? This had a height of 1, and now it's going to be half as tall as it was. That dot goes to here. This one goes to about here. This one goes to about there. This one goes to there. And that goes, sometimes this messes people up, goes the other way, like that. Final answer looks like that. Okay, thing got squished, half as tall. All right, so this is just kind of sums it up. I think I've summed it up enough for you. This is describing the transformations. All you got to do is say what happened. And this one confuses people sometimes. If I put it this way, I think you'll like it better. Do you get that x over 4 and 1/4 x are the exact same thing? Okay. So then, is this 4 times taller? No. What is it? It is 4 times wider. How come it's not 1/4 as wide? Because you can't trust the stuff on the inside. So it's 4 times wider. So that's all you'd write. 4 times wider. If you wanted to say that it was the official way, you would say it's officially a horizontal stretch factor 4. As in it's 4 times wider. Now, if you say 4 times wider versus horizontal stretch, I will on the test have to take off half of a point, because that means you don't know how to say it correctly. So 4 times wider makes me get that you understand it, so I'll give you half. But horizontal stretch factor 4 is the way you'd have to say it on the test. Okay? This one. Is that going to be a stretch or a shrink? That's the key word. It's a shrink. Seems like it should be a stretch, but it's a shrink. So is that horizontal or vertical? Remember, it's high O. It's horizontal on the inside. So that is a horizontal shrink. And it can be confusing on what to use. Should you use a factor of 3 or a factor of 1/3? I'll take either one. I don't care as long as you say shrink. And hopefully you can spell it better than I can. There we go. Shrink. Horizontal shrink factor 3 is the simplest thing. And if I know you're doing a shrink, of course the 3 isn't going to make it get wider. It's going to make it get smaller. So you divide by 3 or multiply by 1/3. All right. And then you should be able to handle something like this now. You could actually graph that. It includes a stretch or a shrink. In this case, it's on the outside, so that's an up, down, and we trust the stuff on the outside, so it's half as tall. So the V shape would be half as tall as it used to be. You already knew how to do this part. That was an up-down flip. This was an up-down move, moving it up 7, and that was left 5. All right. So, your worksheet called stretches and shrinks worksheet A. It's due tomorrow. And that 2-minute teacher thing that I had you do for homework after the test, that's also due tomorrow. It was due today, but I'm not grading it till tomorrow. So if you haven't got it done, get it done. And I'm going to sum up one last thing since I'm doing the recordings for all the classes. Make sure you get this. If you had something like this, y equals -3, parentheses, x minus 4, parentheses, squared plus 7, you should now be able to name all of those things and the right order that they should be done in. Where do you start, inside or outside? Inside. Inside. So we would do this first, which means which way?
Toward the right.
Right 4. I'm going to say the word right first, but otherwise you're correct. Right 4. Number 2, I move to the outside. And of these two things, they're going to be first because they're multiplies, and that's an add. Of these two things, you remember the gymnastics reference I gave you? Stretch before you shrink. Now, you can actually reverse those, and I would accept it if you'd reverse them, but I think you should do the stretch, and that is a vertical stretch of factor 3. And the last, or the other part of that is the flip. Okay, and that's a reflection over, and it's up-down. So if you're going up-down, it's going over the x-axis. And number 4, and we'll go to the last thing, which is this 7 here. So it's up 7. Okay, that's the right order to do it in, and all the things that you need to know about stretching and shrinking. All right, that's it for today.